So hello everyone, welcome to Guwahati Meetup. The topic for our today's meetup is deploying Mule app to CloudHub 2.0 using GitHub Action, and Ashish Jha is our speaker. So before we start, some safe harbor statement. Both the speaker and the host are organizing this meetup in individual capacity only. We are not representing our companies here. This presentation is strictly for learning purpose only. Organizer or presenter do not hold any responsibility that same solution will work for your business requirement. This presentation is not meant for any promotional activities. Some housekeeping. So the recording of the session will be uploaded in the meetup page within 24 hours, and I will also post it in LinkedIn. If you have any question, just feel free to unmute. You already have mic access. Unmute or put it on chat. You can ask it anytime. And at last, once the meetup is over, you will get the feedback form. So we'll request you to fill up the feedback form and let us know how the meetup was, what are the next topic you want. If you want us to improve in some way, we can do that. So please share the feedback with us. Now I'm the organizer for the meetup for Guwahati group. So a small introduction from myself. So I'm a MuleSoft ambassador as well as speaker. I lead Guwahati and Lucknow group. I'm a certified developer and architect. I have overall of 8 years of experience and 6 years in Mule. I am certified MuleSoft industry and GTM champion. I have some certifications, always Delbumi and GCP. I write technical blogs and create technical videos. I own a patent for developing a portable washing machine, and I work as a social solution architect in Apsero. So that's pretty much from my end. Uh, Ashish, should you like to introduce yourself?
Thank you, Abhishek. Hi, everyone. My name is Ashish Jha. This is my first meetup as a speaker, and I'm working as a senior software engineer at Epicero. I have around 2 years of experience in MuleSoft development, and I'm a certified MuleSoft developer, and I'm looking forward to this meetup. Thank you.
Thanks, Ashish, and all the best for your first meetup as a speaker. So I
Thanks,
hope
Abhishek.
maybe I will stop sharing and you can take it up.
Sure. Okay. Please let me know when my screen is visible.
Yeah, it's visible.
Okay. So our agenda for today would be understanding CloudHub 2.0, GitHub Actions deep dive. Then we'll ensure security in our project, and we'll configure our project according to the configurations that are required for the CloudHub 2 deployment using Mule Maven plugin. Then we'll set up our GitHub repository with a workflow file, and then we'll build the deployment workflow. And after that, I'll have a hands-on demonstration for all the process. So first of all, understanding 2.0, CloudHub 2.0. So CloudHub 2.0 is an advanced and improved version of the MuleSoft CloudHub platform. It is a cloud-based integration platform as a service that facilitates the deployment, management, and scaling of MuleSoft applications in the cloud. The two key elements of the CloudHub 2.0 architecture are the shared global regions and endpoint platform services. The endpoint runtime manager, which gives you the access to these two components, works in tandem with them to run your integration applications. Some key features for CloudHub 2.0 are enhanced scalability and performance. So CloudHub 2.0 leverages cutting-edge technologies to provide better scalability and improved performance for Mule applications. It can handle high volumes of data and increased workloads, ensuring seamless integration and experience. Another is global multi-region deployment. So CloudHub 2.0 allows deploying applications across multiple regions worldwide, enabling a global reach for your integrations. Users can choose specific regions to ensure optimal performance and compliance with the data residency requirements. Then we have Dockerized runtime environment. So CloudHub 2.0 utilizes Docker containers to package Mule runtime environments. This enables faster deployment, consistency, and isolation for each application, ensuring smooth and reliable execution. For another key feature, we have auto scaling and high availability. So this is very important. CloudHub 2.0 automatically scales up or down based on traffic and demand, ensuring optimal resource utilization and cost efficiency. High availability feature ensure that your applications are resilient to failures and provide continuous service. In the last, we have advanced monitoring and analytics. So CloudHub 2.0 provides comprehensive monitoring and analytics capabilities to gain insights into application performance and health. Customizable dashboards enable real-time visibility into integration processes, facilitating quite quick issue resolution. So, in conclusion, CloudHub 2.0 is a robust and feature-rich platform for deploying Mule applications in the cloud. And by combining CloudHub 2.0 with GitHub Actions, we can achieve efficient and automated application deployment, boosting productivity and reliability. Then we have Mule Maven plugin, which we are going to use in our project. So Mule Maven plugin is a powerful tool provided by MuleSoft to facilitate the deployment of Mule applications. It streamlines the process of building, packaging, and deploying Mule applications to various deployment targets, including CloudHub 2.0. There are four authentication methods in Mule Maven plugin. First is username and password. In this, we use a CloudHub 2.0 username and password to authenticate, which is basically our Anypoint platform username and password. Then we have connected apps. Okay. We use connected app to perform the authentication programmatically by communicating with Anypoint platform. uh, One thing to note that connected app credentials must have the design center developer access scope to be used while deploying applications to CloudHub 2.0 while using Mule Maven plugin. Then another we have server. So use credentials. Server uses credentials stored in Maven server configured inside the Maven settings.xml file in your system. Then we have authorization token. So authorization token uses an authorization token to access the platform, and identify management for a list of supported single sign-on SSO types. In this demo, we are going to use connected apps credentials in settings.xml file to authenticate ourselves. Some key features and benefits for Mule Maven plugin are simplified deployment. This plugin simplifies the deployment process by abstracting the complexities of packaging and deploying Mule applications. Developer can focus on writing code and let the plugin handle all the deployment logistics. Then CloudHub 2.0 integration. The Mule Maven plugin seamlessly integrates with CloudHub 2.0, enabling easy deployment to the MuleSoft CloudHub platform. Another thing is CI/CD compatibility with Mule Maven plugin. So this plugin is an excellent fit for continuous integration and continuous deployment pipelines. It can be easily integrated with popular CI/CD tools like GitHub Actions, Jenkins, and other tools. Then it has runtime capabilities. So Mule Maven plugin works seamlessly with various Mule runtime version, ensuring compatibility and smooth deployment. So how do we use Mule Maven plugin with GitHub Actions? So we need to integrate the plugin into our MuleSoft project Maven build configuration, and we use Maven profiles to define the environment specific configurations for each deployment target. Okay. Then we take a deep dive into GitHub Actions. So before GitHub Actions, we need to know what is DevOps. So I think everyone knows about DevOps. So basically, DevOps is a culture which promotes the collaboration between development and the operation team to deploy the code faster in an automated and repeatable way. So DevOps basically helps deploy your code in faster and effective manner and helps both the developer team and the operation team. Some key benefits for DevOps are faster time to market. So DevOps automates and streamlines the development and deployment process, reducing the time it takes to release a new feature and update to the market. Then we have greater reliability and stability. Continuous monitoring and automated testing help identify and fix issues early, leading to more reliable and stable applications. Then we have reduced deployment failures and rollbacks. For this, automation and standardized processes minimize human errors. In DevOps, we always automate and standardize the processes that are used to deploy applications, reducing the likelihood of deployment failures and need for rollbacks. Then continuous monitoring and feedback. DevOps practices enable continuous monitoring of applications in production, providing valuable feedback for further improvement. Then one last benefit would be seamless integration of development and operations team. So what DevOps does is it bridges the gap between developers and operation team, fostering a united team that shares responsibility and ownership throughout the software development lifecycle. Then we have CI/CD. So CI/CD is an acronym for continuous integration and continuous delivery. It is a software development practice that emphasizes automation and frequent integration of code changes into a shared repository. Continuous integration refers to the practice where developers works on different Git branches and constantly merge the change code to a central repository. The code is merged to a working branch where the code is built, tested using the automated workflows. This makes sure that all the merged code are together functioning properly and are well tested. Then in continuous deployment, we have continuous deployment uh, uh, is where the merge code is tested from the central repository and it is released into production environment using an automated process and is made available to the customers for use. Some benefits for CI/CD are improved software quality. So, continuous testing ensures high reliability and reduces defects in production. Enhanced collaboration. So, we have CI/CD that fosters seamless teamwork, promoting better communication and innovation. So, as CI/CD is part of DevOps, so both foster seamless teamwork between the developer team and the operation team. Then we have improved testability. You can integrate your unit test cases and integration test cases with your automated pipeline, and it will definitely improve the customer satisfaction also because it would have less bugs and rollbacks. Then reliable deployment. Consider consistent and automated deployment, reduce deployment failures and rollbacks. With CI/CD, faster, consistent, and reliable deployments can be achieved, which will empower the development team as to focus on innovation and delivering values. Then we have GitHub Actions. So GitHub Actions is a CI/CD platform provided by GitHub. It enables automation of workflows, including building, testing, and deploying applications. It allows developers to automate various tasks and workflows directly from their GitHub repository. With GitHub Actions, developers can define custom workflows as code to build, test and deploy their applications, making it easier to maintain, collaborate, and scale their software development process. Some key features for GitHub Actions include workflow automation. So developers can automate tasks like code compilation, running tests, and deploying applications with YAML-based workflows. Then we have event-driven triggers. So workflows can be triggered by various events such as a code push to the repository or a pull request or schedule intervals. Then extensive actions marketplace we have for GitHub Actions. GitHub Actions offers a marketplace of pre-built action, allowing developers to leverage a wide range of community contributed integrations. Then we have security and isolation. So workflow execute in isolated environments and ensuring complete security and data protection. Now we are going to ensure the security in our project. For this, we are going to use connected apps and we are not going to use the credentials of our anypoint platform. So connected apps feature provide a framework that enable an external application to integrate with Anypoint platform using APIs through OAuth and OpenID Connect. In MuleSoft, connected apps are mechanism to securely integrate external services with Anypoint platform, which includes CloudHub and other MuleSoft services. Connected app help user to delegate their access without giving their sensitive credential or giving full control of their accounts to a third party, or any action taken by connected app are audited and user can also revoke at any time. uh, then key features for connected app includes scope based permission, easy integration, and centralized management. Now we need to configure our project. So for configuring our project, first we need to include the CloudHub 2 deployment configuration inside the Mule Maven plugin. For this, we have different parameters. So I suggest for each and every parameter, you go and visit the MuleSoft documentation for CloudHub 2 deployment of Mule Maven plugin. But here we are using a URI which is optional. If it is not provided, the default value is set to https anypointmulesoft.com. Then we have provider, which is MC. So this is a required field, and for CloudHub 2 deployment, it should be set to MC. Then environment, so we can set our environment either sandbox or production design, whatever we want. Then CloudHub target would be CloudHub US East 2. This is a shared space. Then Mule version we are using 4.4.0, and for authentication I'm using a server with name CA Anypoint credentials, which I'm going to provide in my settings.xml file. Then there is application name and replica. So how many replicas do we want, and how many vcos we want for each replica. I'm also using skip deployment verification. So this is optional, but I'm setting it as true. So it skips the deployment verification and it does not wait for the deployment to complete, and it completes your workflows. Here I'm also setting the object stored v2 to true, which says that our application is going to use the object stored v2. Then comes distribution management. So distribution management in Mule Maven plugin simplifies the process of deploying Mule application to different deployment targets, making it easier to manage and distribute the application in various environments. Here I have provided my distribution management ID as CA Anypoint credentials, which is again the uh, client ID and secret for my connected app that I'm going to create, and this is necessary for CloudHub 2 deployment. Then we need to set up our GitHub repository. So for again setting up our GitHub repository is very simple task. We just need to follow some simple commands like git init to initialize our local repository, git add to add the contents, and we can use git status to check the status, then git commit to commit the code, and git push to push the code. Then we have GitHub secrets. GitHub secrets are a secure way to store sensitive information such as API keys, access tokens, and passwords. In GitHub repository, secrets are encrypted and can only be accessed by authorized users with appropriate permissions. They are commonly used in GitHub Action workflows to pass confidential data securely to the workflow. GitHub Secrets provide a secure and convenient way to manage sensitive data in a repository while maintaining a high level of data protection and access control. This also allows the developer to securely incorporate secret values into their workflows without exposing them in public repository. So in this demo, we are going to set our client ID and client secret of connected app in GitHub secret, and we are going to provide them using the GitHub secret to our workflow. Then building a deployment workflow. So our deployment workflow is essential for automating the process of deploying a Mule application to CloudHub 2.0. GitHub Action Workflows is a configurable automated process defined in a YAML file that runs in response to specific events in a GitHub repository. It allows developers to automate various tasks such as building, testing, and deploying software applications directly from their GitHub repositories. Some key aspects of GitHub Actions workflow include a workflow file. So the workflow file is defined in a YAML file with a .yaml or .yaml extension. It is placed in .github/workflows directory of the repository, and other one is trigger. So workflows are triggered by specific events, as I mentioned before, such as a push to the repository, pull request, or any schedule intervals. Then we have jobs. So a job workflow consists of one or more jobs, each representing a unit of work to be performed. So jobs can run in parallel or sequentially based on the workflow configuration. In our workflow, we are going to use three jobs, that is build, upload the artifact to Anypoint Exchange, and then deploy, for deploying the artifact to Runtime Manager. Then we have steps. Jobs are made up of one or more steps, each representing an individual task to be executed. Steps are written as shell commands or by utilizing pre-built actions from GitHub Actions Marketplace. Uh, we also have environment variables, so secrets that we provide in our GitHub secrets or environment variables can be defined in repository settings or passed current securely to the workflow to store sensitive or configuration values. Then the last one is output. So workflows can generate output that can be used by other jobs or steps within the same workflow. So now I'll move on to the demo. uh,
Hello,
please.
Ashish.
Yes,
Good morning. So the thing is, for the CloudHub 2.0, first we have to publish the artifact to the exchange. From there onwards, we have to deploy our code to runtime manager, right?
correct.
Yeah. So, I mean, maybe it's not a direct question to MuleSoft, but in this aspect, when we are using any DevOps platform, do we need an artifact or not needed? Because anyway, we are utilizing the exchange right here.
See, earlier what happened if we used to just build and deploy the artifact.
Correct.
So, Anypoint platform on CloudHub 2 needs the artifact from Anypoint Exchange only. So even like I have written blogs on this before. So in earlier blogs, there were only two steps for deploying the Mule application to CloudHub, which was only build and deploy. The build job used to build the artifact, and the deploy job used to take that artifact and deploy it to Runtime Manager.
Correct.
But now there is another step introduced in between, which is uploading to the Anypoint Exchange. So build job builds the artifact, and upload jobs takes that artifacts and uploads it to the Anypoint Exchange, and then the deploy jobs takes that artifact from the Anypoint Exchange and deploys it to Runtime Manager.
Okay. And so, I mean, for any set of API, right, we may can have number of versions. So do we have any limit or maybe size limit in Exchange? Maybe let's say for 500 MB or something like that.
I haven't come across such thing, but I can definitely check for that. I'll let you know.
Great, thank you.
Okay. So let me share my screen. Okay, please let me know when you see the Anypoint platform screen.
Yeah, you can see.
Okay, so our first step would be creating a connected app. So I'll go to access management. This is my trial account that I'm using. And here we need to go to connected apps under access management. And I need to create a new app. Here we can give name to our app. I'm giving Meetup demo connected app, and we need to select this app acts on its own behalf, client credentials. And then I'm going to add scopes to this. So for scopes, I am giving API manager first. So in API manager, I am giving application creator and application viewer. Then I am giving design center permission. So in design center, we are giving design center developer permission. This is necessary to uh, deploy your artifact into CloudHub 2.0. This permission needs to be there. Then I'm going to give exchange permissions. So in exchange, I'm giving contributor, creator, and viewer, and some general permission. Here I'm giving view environment and view organization, and then OpenID. So in OpenID, I'm giving both the permissions, and then I'm giving runtime manager permissions. So in runtime manager permission, I'm giving create application, delete application, download applications, read application, and read server. So these are all the permissions that I have given. Now I'll click next and I'll select my organization, and I'm giving permission for only sandbox environment this time. And these are all the permissions that I have gave. API manager, we have application creator, application viewer. In design center, we have design center developer. In exchange, we have exchange contributor, exchange creator, exchange viewer. And in general, we have a view environment, view organization. And in OpenID, we have profile and client identity for Google's WIF. In runtime manager, we have create application, delete application, download application, read application, and read server. So I'm going to add these scopes, and going to save this. So our Meetup demo CA, this connected app is ready. And now I'm going to create one MuleSoft app. So for this purpose, I have already created a MuleSoft application. This is a very basic application. I have two files here, that is main.xml and global.xml. Inside main.xml, I just have a transform message for payload, which gives status as success and message as hello world. I'm setting HTTPS variable as 200, and I'm just logging the payload here. In properties, I have given my http dot port as 8081 and http dot host as localhost. Inside global, okay, I think I have made this as global. No worries. So inside global, I have configuration properties and the http listener config. I'm just going to delete this, and we'll keep this one only. Let me just, it's already running. And it,
Meanwhile, we have a question now, Ashish.
yeah, please.
Sarnik is asking, like, why do we need the OpenID permission?
So OpenID permission is not required for this one, but if you are going to use the OpenID authentication for your Mule Maven plugin, that you then you can use that. So for just a usability purpose, I have given that permission also. So our application is deployed and it is working. So now what we have to do is I'm going to the repository directory of this in my local, and we have to create a .maven folder here. And inside this .maven folder, I am going to create a settings.xml file. And inside this settings.xml file, I am going to give the settings for the server. So I have already prepared my settings server. I'm just going to copy and paste it. So inside this, I have a server with ID as CA anypoint credentials, which is connected app anypoint credentials. Username is client, and the password is client under CA underscore client underscore ID, C underscore client underscore secret. So you can change this as it suits you. So I'm going to close this, and I'm going to open my project again here. just going to refresh it. And now I'm going to the pom.xml file here, and I'm going to change the group ID with my group organization ID of Anypoint platform. So again, in my users business groups, I have this demo organization here. I'm going to copy this business group ID, and I'm going to replace it inside the group ID here. I'm going to remove this snapshot from the version here, and this is what we have to do in the group ID and version. Now we'll go to the Mule Maven plugin. Configuration extension. So this is our Mule Maven plugin, and after this we have to add our CloudHub 2 deployment configurations. So again, I'm going to copy the configurations that I've already created, and I'm going to paste it here. So here I have set the URI to https endpoint.mulesoft.com. Provider is empty MC. Environment is sandbox. This is again case sensitive, so you have to take care of that. Target is CloudHub US is 2. Mule version is 4.4.0. Server is CA anypoint dot credentials, which we just created in our settings.xml file. Application name is let me change this to Meetup demo project v1. Replicas is 1. vCourse I'm going to use 0.1, and I'm using skip deployment verification. This I'm going to set as true in the pipeline workflow. Then I have set object store v2 to true, and then we have to add our distribution management. So again, I have this distribution management here. You can get these things from the documentation of Mule Maven plugin also. So after the build tag, I'm going to use this. So again, here in the ID, I have given the CA anypoint credentials from the settings.xml file, and I have replaced the organization ID with my project group ID, which is again this one that I just updated. So this is all that we have to do. These are the basic things that we have to do in our project to deploy it to CloudHub 2.0. Then I'm going to create a repository on GitHub. So here I'm going to create a new repository. And now I'm going to initialize my project directory here. So I'll open a command prompt. So first command would be git init to initialize the Git repository. Then I'm going to add the changes with git add, and we'll check with git status. So all these things have been added. Now I'm going to commit these changes. And then I'm going to change my branch to main because I'm not making any other branch. So I'm just really going to use the default branch. And then I'm going to add the remote. So I'm going to copy my git remote from the repository that I just created. And then I'm going to push these changes. So I pushed these changes. Let me just refresh the repository, and here you can see all the code changes that we just did is in my GitHub repository. Now I'm going to create the secrets. So we'll head to the settings. Inside settings, we need to go to secrets and variables from the left hand side menu. Inside that, we have actions option here. So click on actions, and we need to add the new repository secret. So I'm going to add new repository secret. Here the client ID and secret name would be same as the secret that name that we used in our settings.xml file. So that is ca underscore client id. I'm going to copy the connected app id here. So I'm going to copy it and I'll paste it here. Add secret. Then I'm going to add a new repository secret with client secret. So ca client c underscore client underscore secret and the connected app client secret. We'll paste it here and add secret. So as you know, these are secure and this won't show to anyone. If you need to update this, you have to update it whole. You can't get to know what secret was before. So we have added our secret here and we have added our code also. Now we are going to create a workflow. So let me just go back to actions here. On the tab, this tab we have actions, and I'm going to select this simple workflow configure. I'm giving the name as pipeline.yaml, and I'm going to change this code, and I have my pipeline ready here, which I'm going to copy this and I'm pasting it here. So you can see the name of this pipeline would be build and deploy to sandbox. It works on a push and it works on branch main. So if there is any push on main branch, it is going to be triggered. You can also add pull request here and different branches also that would also act as a trigger. So in this workflow, I have three jobs. First is build, then I have upload, which is going to upload the artifact to CloudHub Anypoint Exchange. And this step needs the build step. And then we have the deploy job. And this deploy job needs the uploads job here to be completed first. So in the build job, this runs on Ubuntu latest. And these are the environment secrets. So client ID and client secret of our connected app. Then in the steps we have actions checkout. So this checks out the repository code. Then we have actions cache. So this caches the Maven repository to speed up future builds. Then we have Java, setup Java. So this setups the JDK to 11 using the Zulu distribution. Then we have print effective settings. So this what it does is it prints the effective Maven settings, and this is optional, but this can be used for the debugging purposes. Then we have build with Maven. So this command builds the MuleSoft project using Maven and stores the resulting jar file in the target repository. Then I'm using stamp artifact file name with commit hash. So this step runs uses a script to stamp the artifact with file name. Artifact file name with the commit hash of the latest commit using the git ref parse, and it remains the jar file by appending the commit hash. Then we have upload artifact. So this uploads the artifact resulting jar file to the workflow artifacts with the name artifacts. Then we have upload job. So again, this needs build to build job and will run only if the build job is successful. Then it runs on Ubuntu latest version of Ubuntu. It also have the environment client ID and client secret for the connected app. Then steps of this job include again the checkout. So this checks out the repository to speed repository code. Then we have actions cache to this caches the Maven repository to speed up the future builds. Again, same as the above step, and this uses also actions artifact master, and this downloads the artifact from the build job. Then we have Maven deploy here. So this deploys the artifact to the MuleSoft exchange using Maven and the provided settings.xml file. Then we have deploy job. So uh, this deploy job needs the upload job to be completed, only then it would run. Then it also runs on the latest version of Ubuntu operating system. It also has environment secrets, and steps also includes actions checkout, actions cache, just like above. and it also uses the Maven repository to speed up the future builds, and then it downloads the artifact from the upload job. Then the last we have Maven deploy. So it deploys the artifact to MuleSoft sandbox using Maven with the additional option I have given Mule deploy and skipping test and deployment verification. So deployment verification I have set it to true here, and I am skipping tests here. So this is our pipeline workflow. I am going to commit this, create pipeline. Going to use the same commit and commit changes. So as I have committed the pipeline for the first time, it is going to run. So let's check this. It has started. So create pipeline.yaml is running. First is build job. And here I will open the anypoint exchange also. So this is the build job that is running. So for the first time, it is going to take some time. And for the further runs, it is going to use the cache values that it is going to cache.
Hi, Ashish. Quick question.
Yes, yes.
In the form.xml, if you can switch back to the notepad or something, the form. You mentioned the object store in the integration, but in the when you provided a scope, you didn't provide any scope for the object store, but there was a scope explicitly for an object store. So, can you explain why it is mentioned here but not in the scope?
Okay, so I think I must have missed that because I haven't faced any problem since I'm not using this object store in the uh, this simple
application.
application. Yeah. So
Okay.
I think that scope should also be added there if you are going to use any object store.
Okay. Perfect. Okay. Yeah, that step was missed, so I was not
Yeah,
sure.
no, absolutely correct. So as you can see, this upload job has been completed. So we can go to our anypoint exchange here, and here we can't see our artifact. But if we change this address with and we just need to append this and type equals app, then we can see the uploaded artifact. So here you can see Meetup demo project, and these are the previous artifact that I was testing with. So here Meetup demo project, you can see the version is 1.0.0, and then okay, the deployment has also completed. So let's go to our runtime manager. So again you are you can see that this is still running, this has not been completed, but our pipeline was completed since we use skip deployment verification, so it did not verify the completion of deployment. So it is running, we can wait for it. Here you can also set the monitoring in the deployment configuration pom.xml. In this Mule event plugin configuration, deployment configuration, you also have the option to enable the MuleSoft monitoring. So you can do that also. So our application has been deployed. Let's just check this. So base path was API and the endpoint was hello. And I'm going to remove this S. We are using HTTP. So here you can see our application was successfully deployed. Now what I'm going to do is I'm going to make a small change in my application. So let's just add a timestamp here. And every time we need some change to our application and we want to deploy it to CloudHub 2.0, we need to change the version of our artifact also. So this is going to be 1.0.1 now, and let's just get back. I'm going to add it, check the status. So there are two changes, so we can commit and we can push. Okay, let's just take a git pull because we made some changes to our directory, our repository, because we added a pipeline file, so it needs to be taken here also. And now git push. Okay, I'm going back to my repository here. Good. So updated version, I have made a commit. Then we go back to actions, and you can see this job has started. Again, build, upload, and deploy. So first it is going to build it. So this time it is going to take less time than the first time we deployed it. So you can see this has already this is already going to be completed. So build is completed. Now the upload job is running. So upload to CloudHub Exchange is completed. Now we can go back to Exchange. Let me go back to Exchange here. All assets and type equals app. Okay, we had this here. Okay, Meetup demo project, and you can see the latest version is 1.0.1. So our deploy job has also completed. So we head back to our runtime manager. And it is deploying again, updating the app. So this way you can deploy your applications to CloudHub 2.0 using GitHub Actions. And if you have enterprise credentials for MuleSoft Nexus repository or maybe Nexus repository, you can also include a test step to run the emulate and test your application after build. So there would be four steps: build, test, upload, and deploy. But that needs the Nexus repositories credentials. It should be deploying anytime now. Okay, it's complete. Let's go back and send a request to HTTP. And you can see we got a timestamp. So our application with the updated version has been deployed. So this way you can deploy your applications to CloudHub 2.0 using GitHub Actions and Mule Maven plugin. So that's all from my side, and you can get this source code if you want from the GitHub repository here, Ashish Jha slash meetup demo.
Can you share the link, Ashish?
Sure, I can share. So this is a GitHub repository, and I'll stop sharing now.